Welcome, Pure Maths 3 students. Today we're doing expressing something that's like a sine theta plus b cosine theta in the form of r sine bracket theta plus or minus alpha, or r cosine bracket theta plus or minus alpha. So these are expressing something in those forms requires us to use or understand the addition rules, okay? So let me just give you an example. I suggest strongly that you read the introductory material to the exercise and look at their examples, but I'm going to do a few from the exercise for you briefly. Okay. In number one, I've got 1a, I've got 3 sine theta plus 2 cosine theta. And they want me to write it in this form, r sine theta plus alpha. Okay, that's what the form that they want me to write that in. Now, if you look at this here, I hope you realize that we could write that out like this, r sine theta cos alpha plus cosine theta sine alpha, and of course if we expand we're going to get r sine theta cosine alpha plus r cosine theta sine alpha. So that's the addition rule, right? Now, if you look at what we do have, we've got a sine theta here, which is this sine theta here. Now, if you see that, that means that this r times cosine theta must be equal to this 3. And then let's look at the next one. We've got a cosine theta here, and we've got a cosine theta there, which tells us that this sine theta times r must be equal to this 2. So r sine alpha equals 2. Now, what we can therefore say is that if we put r sine alpha over r cosine alpha, that's going to equal 2 over 3. So I've just put one side over the other, and that cancels out, and so we know that tan alpha equals 2/3, and therefore alpha is equal to the inverse tan of 2/3. So now we know that alpha is, if we chuck this into a calculator, I think we're giving it to degree, yeah, we're doing degrees, so we go inverse tan 2 over 3, and this gives us 33.69 to 2 decimal places, which is what they want. So 33.69 degrees. Okay, so that's the first bit. Now, the second bit, finding r. So we've found out what we've found this bit out over here. Okay, we found that out. We just need to find out the r. Okay, so what I'm going to do is I'm going to go r cosine alpha, and I'm going to square that, equals 3 squared. And I'm going to do the same to the other one. R sine alpha squared equals 2 squared. Now, what do we get in those cases? We're going to get r squared cosine squared alpha equals 9. And we're going to get r squared sine squared alpha equals 4. Now, I'm going to add them together. I'm going to go r squared cosine squared alpha plus r squared sine squared alpha equals 9 plus 4. Then I'm going to factorize r squared cosine squared alpha plus sine squared alpha is equal to 13. But I know that inside that bracket, that's 1, because sine squared alpha plus cosine squared alpha is 1. So r squared equals 13. So therefore r is equal to square root 13. And now I'm ready. I can write my final answer. Square root 13 sine theta plus 33.69 is equivalent to 3 sine theta plus 2 cosine theta. Now, I think that's all it wanted me to do, right? So I've done the job that I've been asked to do. I just want to comment a little bit on this bit here. To find r squared, you don't have to go through all of this rigmarole. Once you know how that works, you can say r squared equals 3 squared plus 2 squared. Okay? And so r is equal to the square root of 13. Now, I feel like it would be useful for us to try another one. Maybe this time we will do one where we're using the cosine rule, the cosine addition rule. So I'm going to go to number 3. 3a. Okay, and I want to express cosine theta subtract sine theta as equivalent, or we want to put it into the form of r cosine bracket theta plus alpha. Okay. Now, the first trick to remember here is that I can use the addition rule to go, this is going to be r cosine theta cosine alpha minus sine r sine theta sine alpha. Okay, if you're a little bit shady on that, you want to go back to your addition rules on page, let me just check, where is it? I think it's, oh, here we go, addition formulae, so page 52. Okay, so I'm using the cosine addition rule, or when we've got a minus b, or theta, theta plus alpha, that's what we're going to get. So if you're a bit shady on that, you might want to review. Okay, so I'm okay with this pink thing here. Now, what do I notice? Well, I've got a cosine theta here, and I've got a cosine theta here. I've got a sine theta here, and I've got a sine theta here. Now let's look at the coefficient. Well, in this case, it's 1 cosine theta and 1 sine theta. So we know that r cosine alpha is equal to this one here, and we know that this r sine alpha is equal to this one here. Okay, so I can straight away go r squared equals 1 squared plus 1 squared, so r is equal to the square root of 2, and I know that tan alpha is equal to 1 over 1, or 1, so alpha is equal to the inverse tan of 1, which is 45 degrees. So if I'm going to write it in the form that I've been asked, I'm going to go square root 2 cosine theta plus 45 degrees. Alright, so that's another example. Just checking out, this is all good. Okay, let's try one more example. Okay, I'm going to go do 6a. I need to express square root 3 sine theta minus cosine theta, and I need to do it in this form here. I need r sine theta minus alpha, and then I'm going to use this in part B to solve something. So let's just remember our addition rule. So this is r sine theta cos alpha minus r cos alpha, theta sine alpha. We have a look here. We've got a sine theta, corresponds to that sine theta. We've got a cosine theta, corresponds to this cosine theta. Okie dokie. Now, that means that this r and cosine alpha, when they multiply together, must be equal to this square root 3. And additionally, this r here and this sine alpha must be equal to the coefficient here, which is 1. So r cosine alpha equals 1. Now we know that r squared is equal to square root 3 squared plus 1 squared. So r is equal to the square root. Now when we do that, we're going to get square root 4, which is equal to 2. Okay, I think that's right. And then we know that tan alpha, I should have a sine alpha here, sorry. You've probably picked that up already, that should have been sine alpha. Okay, tan alpha is going to be 1 over square root 3. And so alpha is going to be the inverse tan of 1 over square root 3, which is equal to 1 over square root 3 is equal to, you Larry should know this, 30 degrees. Okay, so now we can therefore write this as 2 sine theta minus 30 degrees. Now, it says in part B, hence, which means we're going to use this that we've just figured out. We've got to solve square root 3 sine theta subtract cosine theta equals 1. For 0 is less than or equal to, theta is less than or equal to 360 degrees. Okay, now the reason that what we've done is helpful is now we have everything in terms of sine. So my next line would be to divide by 2. Then I'm going to go theta minus 30, and I'm going to get my principal value. So theta minus 30 degrees is equal to sine, inverse sine of 1/2 is 30. Now at this point, I'm going to go and have a look here. Okay, if I have theta minus 30, how does that change my range? Well, I have to subtract 30 from here, and I have to subtract 30 from here. Okay, so that will be my range. Now if I look at my graph, I've got my principal value at 30, which is there. I've got another one here. And I also have one way out here somewhere. So these are the ones that I'm going to worry about. So I've got 30 and 150, I think. Yes. So therefore theta is going to be 60 or 180 degrees. Now let's check the answer book. Have a look that we got this right. I think that makes sense to me. Let's have a look. Yep, looking good. Yeah, and we're good. Okay, so that's a little introduction to that lesson. I hope you go well with that, guys. Let me know if you're having any problems, and take care.